So yesterday we talked about roots, and roots were what to the equation? Solutions, right? So you're realizing now that in math, specific concepts have their own like variables attached to them, or their constants attached to them, like right? Like h and k is the coordinates of the vertex. A, B, and C are the coefficients in the standard form of the equation. And then P and Q are the roots of a quadratic equation. So suppose P and Q are roots of an equation. Then x minus P and x times x minus Q is equal to 0. Okay? So once you have the roots, you can put them into two separate binomials, x minus P, x minus Q, multiply them out, and then you will have the standard form of the equation. Okay? All right, so take a look here. We have two roots, -2 and 7. So here we have a parabola, roots -2 and 7. We want to write the equation in standard form. So you take the first one and you do x minus that one, so it'll be x plus 2. And then x minus 7 is equal to 0, right? And then when you FOIL this, you're going to get x squared minus 5x minus 14 is equal to 0. If you still have issues with multiplying out two binomials, you can come to bonus and we'll review some of the algebra. Okay, here I have x minus a third, x minus 6 is equal to 0. Okay, now I have a fraction. Fine, so I have a fraction. We're still going to multiply in the same way, right? So let's do this. So first terms give you x squared. Outer terms minus 6x. Inner terms negative 1/3 x. Last terms positive 6/3, which is 2. Equal to 0. Okay, now that fraction, right, it's still there, which I don't like it there. I want to get rid of it. So how can I get rid of it? Multiply through by 3, right? So you can multiply the whole thing by 3, and I get 3x squared minus 18x minus x plus 6 equal to 0. And then finally, 3x squared minus 19x plus 6 equal to 0, right? So remember here, A, B, and C have to be integers for the standard form. Cool? All right. Next, one of my favorite properties in math, right? Yep.
Could you just minus the
Subtract.
Yeah, subtract the 1/3x?
You can, but then you have all these fractions still remaining. And remember what we said up here, that A, B, and C must all be integers. So you still have to multiply it out by 3 in order for them to be integers. Okay, one of my favorite properties is the zero product property. For any real number A and B, if A times B is 0, right? If A times B is 0, then either A must be 0, right? If you multiply two numbers and you have to get a 0, either A has to be 0 or B has to be 0, or both of them have to be 0 together, right? Kind of common sense, right? So why is that important? Because it lets us solve equations, right? And let's see how we can use that to solve equations. Okay, so how do we factor trinomials? There are 3 sort of, steps or things to do. First is the GCF, right? Identify if there's one factor that you can take out. Then you're gonna factor a trinomial, right? So these are basically like the opposite of foiling, right? And then there are some special cases. So we have perfect square trinomials where, look, you have a squared, b squared. So you have a perfect square, and then here it's 2 times AB. So these factor like this, A plus B squared. You guys remember this from last year and the year before? We'll do, we're gonna do examples. And then you have difference of two squares, where difference of two squares is this, perfect square, it's got to be a minus in the middle. And in that case, you take the square root of the first, you take the square root of the second, and then you do plus minus. Okay, so let's do some examples, and then we'll see if we have any more questions. Okay, so let's factor and solve this one. So remember, to set the question straight of do I just factor or do I factor and solve, whenever you have something equal to 0, those are the ones that you're going to solve, right? But if it's just this without it equaling to 0, that's not an equation for you to solve, right? Okay, so in here, you first have to check, can I factor out a trinomial? From here, I can take out a what from both of them? 4x. So I get x squared, just x plus 4. And then you check, can I factor any of them further? No. So now this is the zero product property. One thing times another is equal to 0. That's when you can set the first one equal to 0, the second one equal to 0. If this was not a 0, you couldn't do that, right? So if this was a 1, you can't say 4x equals 1, x plus 4 equals 1, because it's not the one product property, it's the zero product property. You get it? So here we do 4x is 0, x plus 4 is 0, so I get x is 0, x is negative 4, and those are my two answers. Okay. What do we factor out of the next one? 5x, and I get 4x plus 3. So 5x is 0, 4x plus 3 equal to 0. Here I get x is 0, 4x is negative 3, x is negative 3 over 4. It's warm in here. Okay. All right, so on the next page, I have like a whole page of factoring problems. Okay. Right, so let's take a look at this one. Is there anything I can factor out? A GCF? No. There isn't a GCF I factor out. So then I try to see if there is a pattern. So take a look at this one. I have perfect square, right? Okay, what's the square root of this? 4. And you see how this is twice that? So this is a good candidate to factor like this, a perfect square trinomial. So what I would do is, I say this squared equals 0, square root of the first one, square root of the last one. If it's a plus here, I put a plus there. Okay? Now, just kind of check. This is the important part because you have to make sure that it works. 2 times 4 times x has to be positive 8x, right? Okay. So now, how do I solve for this? It's something squared equal to 0. The square goes away because you can square both sides. So you can just say x equals negative 4. Okay.
So nothing with the 16?
No, because the 16 got factored into x plus 4. Now, before I take questions, some of you might tell me, what if I get this? Right? What if I factor and I get this? Okay? Right. That's also the same because it's equivalent to this. However, now that we are in Algebra 2 and getting into upper level math, it's so important for you guys to recognize that this is actually that. So even if in your mind you write this first, go ahead and take the other step and say x plus 4 squared, because it's very important for me that you recognize that. Okay, yes. So I did x plus 4 equal to 0 and x equals negative 4. Okay, the squares go away, yeah.
Is there a way to tell?
Can there be a special pattern? This is a perfect square, right, of 2x. This is a perfect square as well. So let's see if we can do it in the same way. So square root of this one, 2x. Square root of the last one, 3. There is a minus here, so I put a minus there. Okay, let me check. 2 times 3, 6, negative 6, times 2, negative 12x. So yeah, that worked. Okay? Now, the square goes away, right? So this is just like saying 2x minus 3 is equal to 0. 2x equals 3. X is 3 over 2. So you see how both of these have only one solution? So like what we talked about before, these are the ones that only hit the axis at one point. Yes?
I'm kind of confused on the last one because negative 3 squared plus 2x isn't negative 12x.
Right, but it's not squared. It's 2 times negative 3 times this.
Oh, I thought it was.
No, not the square. 2 times 4 is 8.
Oh.
Okay? All right. So this one, I understand that you can just say x is plus or minus 6 for this. But look at what the instructions said. They said factor and then solve. Okay? So you have to bring the 36 over to the other side. Set it equal to 0. Now this is definitely like a pattern, right? X plus 6, x minus 6. So x plus 6 equal to 0. X minus 6 equals to 0. X equals negative 6 and 6. Okay? All right. What can I factor out of the other one? 9x. So let's factor out a 9x. What do I have left? Equals 0. Okay, so what's x equal to from the first one? 0. And from the second one? 1 over 9. Fabulous. Okay. All right. Next one. Okay, I have a trinomial again. Do I have perfect square, perfect square? No. So I have to factor this using two binomials like this. Okay? So first off, I have x and x, and these two terms, they have to multiply to x squared. X squared. Here I need, you guys know this, two numbers to multiply to negative 15, add to negative 2. What do you all think?
X minus 5x plus 2.
Okay, so here x equals 5, x equals negative 3. Okay. This is what I want you to show. Okay, actually, once I do this whole page, I have a little bit about like form. Okay. Okay, here, what are we going to do first?
Move the
Right, good. Yep. Okay, so x. Okay, so if it's minus plus, you know that it's going to be minus on both terms here. Right, so somebody raise your hands. What do you think you get for this one, Olivia? Minus 5, minus 6. So x is 5, x is 6. And what are these that we're solving for? X is 5 and 6. What are these of the quadratic equation? The roots, right? Good. Okay. So, what about this next one? Here, again, not a perfect square on both of them. Okay, so I need two numbers to multiply to 5x squared, right? The only way to get that is 5x and x. There is no other way to combine and get, a product of 5x squared. They're both pluses, so they're both going to be pluses here. Now I need two numbers that multiply to 24, but when I FOIL, I have to get a 34 for the inside numbers. So what do I mean by that? How do I get 24? 2 and 12 is one possibility, right? Or even like 3 and 8. So let's do 3 and 8. And let me show you, this is not the right answer, but let me show you what we're doing here. Once you do this, the outer terms and the inner terms have to combine to 34x. So in this case, I get 40 and 3. There is no way to combine those into 34. So 3 and 8 are not the right product factors. 6 and 4 is another option. So let's see. If I do 6 and 4, now I got 20 and 6. That's 26. So that doesn't work either. But let me see if I can switch them to 4 and 6 like this. And now 30 and 4, that's 34. There is a little bit of trial and error, right? And I know there's lots of things out there. There's an X and a box and a this and a that. I always want to stress the fundamental ways of doing things, right? So guess and check, trial and error is my best way to do these, okay? So 5x plus 4 is 0. X plus 6 is 0. So x is negative 4 over 5. X is negative 6. Okay. Ones like this are, okay, so 15x squared, right? I could either do 15x and 1x or 5x and 3x. So in this case, this is 5x and 3x. If it's a minus and a plus, it's going to be minus minus always. And then I have no other choice but to make this a 1. So let's see, outer, negative 5. Inner, negative 3. Does that make negative 8? Yep. So 5x equals 1. I'm sorry, 5x minus 1 equals 0. 3x minus 1 equals 0. Okay, x equals a fifth. And how about here? X equals a third. Okay, let me talk a little bit about form, okay? It's like in the Olympics, it's like this long spike, and then you go and you just sort of like
Run and throw it.
you run and you throw it, right? Okay, let's take notes. So the height of a javelin in feet is modeled by this. So this is the height, modeled by this. Sorry. This is the equation, okay? Very important. Label what you have. T is seconds. How long is it in the air? So T is time is in seconds. How long is it in the air? Okay. So it's in the air from the time that it left the ground to the time that it got back to the ground, right? When it was on the ground, both times, H is what?
0.
0. Okay? So first, set H of T equal to 0. When I figure out when it was on the ground, right, I can figure out how long it was not on the ground, right? So negative 16t squared plus 79t plus 5 is equal to 0. Okay. When I want to factor, I hate having a negative in front there. So I'm just going to multiply everything through by a negative. 16t squared minus 79t minus 5 equals 0. Okay, now I have to factor this. And before you freak out, it's okay. Yes, big numbers, but it's okay. All right. So the 5, right, there's only one possibility. It's going to be a 1 or a 5, right? So here, let's start out with 16t and t, right, before we split it. And then here we're going to have a 1 and a 5, right? We want the numbers to get big to 79. So I kind of need the 16 to be multiplied by a 5 so I can get a big number, right? That means it's probably more wise to put the 5 there at first, right? So 5 and 1, okay? And I need a negative. I need the negatives to be bigger. So let's make that negative and that positive. Does that make negative 79? This is negative 80. That's positive 1. That's negative 79. Is it an emergency? Can you wait a little bit? Okay. So 16t plus 1 is equal to 0. So t is negative 1 over 16. And then here, t is 5. Okay. We're solving for time. Can it be negative? No. So, right, time can't be negative. So this is it. T equals 5 is when it was on the ground, right? So it was in the air for 5 seconds. Okay, so this is when it hit the ground. Okay. Yep.
What was the negative 1?
The length of a rectangle is 2 feet more than its width. Find the dimensions of the rectangle if the area is 63. When you have a problem like this, the first thing you need to do is draw the diagram for it. This might be a simple one, and you might think, oh, I can do it in the head. I don't know. I can do it in my head. I don't know what Ms. Malik is talking about. Fine. They're going to get complicated. Get used to the format. Okay. So here we have a rectangle. One side, if one side is x, the other one is x plus 2. Okay? And the area is 63. If we're given the area in the problem, you have to start with the formula for whatever you're given. The area of this square is x plus 2, 63 is equal to 63.
Oh.
Yeah? Length times width. X squared plus 2x is equal to 63. How do we solve? Move everything to the same side. I know. At least one person will factor, set it equal to 63, and then say x equals 63, x plus 2 is equal to 63. It's not the 63 product rule, it's the 0 product rule. Okay? So, x squared plus 2x minus 63 is equal to 0. How do we factor this? Right? And then plus 9 minus 7, right? So x plus 9 is equal to 0. X minus 7 is equal to 0. X equals negative 9. X equals positive 7. Okay. Now, what about the, right, you can't use the x equals negative 9, right? Because the width can't be that. So, let's see. The width is the small side and the length is the bigger side. So we say width is 7 feet. Length is 9 feet. Okay. Did my problem specify include units in here? Do the words include units exist anywhere? No. Do I really need to be told to include units when I'm solving a problem like this? No, we're in an honors class. This is just common knowledge that you got to include units, right? So you have to include units.